Good afternoon, everybody. Welcome to NASA's Johnson Space Center here in Houston. Today's post-mission management team briefing is going to be hosted by Leroy Kane. He is the deputy manager of the Space Shuttle program. He's also chairing the MMT throughout the on-orbit phase of the flight. He'll have some opening comments about today's meeting and how the mission's going so far from the MMT standpoint, and then we'll take questions here and out on the phone bridge. With that, I'll turn it over to Leroy.
Okay, thank you, Kyle. Good afternoon. It is great to be here with you again. It's good to have Discovery on orbit and on our way back to the International Space Station. I just have a few brief opening remarks. The launch and the ascent was just beautiful, and the performance of the vehicle was exceedingly good. And we'll continue to look at all that data as we typically do. But we're safely on orbit. The crew is preparing for our rendezvous and docking later this afternoon and this evening, and so we're looking forward to that. We did meet as a mission management team today and talked about a few items. The first item was we had a thruster failure. One of the small, what we call vernier thrusters, failed. That was about 4.5 hours after launch during the on-orbit phase when the crew was in post-insertion and preparing the vehicle for the on-orbit stage. This is one of the small thrusters in the forward part. There's only 2 up there, and there's 4 in the back. And it looked like it was leaking, and it was below the temperature limits in the flight rules. So eventually it failed. Redundancy management automatically failed it out. And then at some point later, several hours later, after the flight control team in the mission evaluation room looked at it, they decided to close the manifold for the forward manifold. So at this point, the vernier thrusters are not available to us. We do have a couple of backup modes to the verniers, and so it's really not a problem for us to use the other thrusters for attitude control and for maneuvers. So we'll go into the rendezvous and the docking portion without verniers available to us. The crew is very well trained for this particular failure mode. They train it numerous times in their preparations for flight, and so we don't have any concerns for that. Talking about ascent and debris and inspection and all of that kind of data, we're pretty much on our timeline so far. We had, the team told us today, I think we had 9 triggers on the wing leading edge impact detection system. Of course, those are not necessarily real indications of anything that impacted the wing leading edge, but we'll go do our data evaluation on those as we normally do. The Flight Day 2 inspection, where the crew looked at all the RCC on the wings and the nose cap, all that went very well. The data is all on the ground and in the building. The team is a good ways through their assessment of all that data. The level 1 assessment is complete, which is to say that there are no significant areas of concern that they've seen in anything in level 1, where they do sort of a broad look. Level 2 is over 50% complete, and so they are at least on, if not ahead of their normal timeline for reviewing all of that Flight Day 2 inspection data. And we'll see some more of that come forward to the MMT in a couple of days here. We also had preliminary reports, what we call quick look reports, in some cases just verbal reports, that the launch pad and the ascent debris looked very nominal in terms of, that is to say, we didn't see much in the way of damage on the pad or the flame trench. Again, this is very preliminary, and we'll get our complete assessment here in a couple of days, but that all looked good. The very preliminary imagery and data review from ascent, the launch video and imagery, as well as the post-MECO external tank separation imagery, folks have done a very preliminary look at that, and that all looks very good. In particular, you know, we were interested in the LOX tank ice frost ramp imagery, and all that looks very good to us at a preliminary look. We've got much more detailed assessment to take place here as we go forward. So overall, very clean ascent, very clean vehicle. The crew is doing great on orbit. They They got up about 12:30 our time today, and they're well into their rendezvous procedures now. And so we're looking forward to a good rendezvous and docking with space station, and we'll get on with in earnest with the mission at hand here for STS-128 and Discovery and the crew. So with that, I'll take any questions you might have.
Okay, we'll start with, I guess we'll do Bill, Gina, and Robert in that order.
Bill Harwood, CBS, with 3. Excuse me, I'm sorry. You mentioned the IFR. Is that based on tank photography? Saw the flash going. Didn't know if y'all have had a chance to look at that data yet. So that IFR is intact?
Right, the ice frost ramp, Bill, yeah, we have, because it was a night launch and night ETSEP, we were relying on the umbilical well camera and the flash that we now have for the umbilical well. And as you know, this time we extended the +X maneuver a little bit so we get to the front of the tank quicker and get a little bit better images of it before it got as far away. This is very preliminary, but from what I've been told, and they'll bring the data in the next couple of days, is what we have seen is what we consider to be normal kind of erosion on a couple of the ice frost ramps on the LOX tank. Don't see any losses, if you will, on the ice frost ramps. Nothing like on 125 or 127 where we had losses on the 718 IFR. So that looked really good to us.
Thanks. And a vernier question. Am I correct that if you lose one and you isolate, then you lose all verns, right? I mean, that includes the aft. You don't get any verns if you lose one.
Almost right. In this case, that's certainly true. We can't lose either one of the forward vernier jets and still fly on verniers. There are cases where we can lose one of the aft side firing, either L5L or R5R. In certain configurations, certainly for shuttle flying alone, we can fly all day long with loss of just one of those. But certainly for the case of loss of one or both of the forward, we can't fly on verniers for attitude control or maneuvers.
And that was my last question, is attitude control. Can you tell me how you do that or what the plan is for that? I know you're going to use Russian thrusters, I guess, to rotate after docking to get where you want to be post-docking, but long term, how do you do that? Yeah,
what we'll do while we're flying along, of course, we have the primary reaction control system thrusters, the PRCS, and so we'll use those both in a PRCS and in an alt-DAP, what we call an alternate or alt-DAP mode that we've been flying with for several years now. It's a pretty sophisticated DAP mode where, based on moments of inertia, the DAP can figure out which jets to fire individually to maintain attitude control and to do maneuvers. So we have both of those modes for shuttle flying alone. And then once we're docked, we do have the ability to use alt-DAP for attitude hold. It's lower priority than some of the other modes of holding attitude for shuttle station combined attitude control. So higher in the priority list are things like the momentum manager and CMG control, and even above our alt-DAP for this particular shuttle station dock configuration, the use of the Russian thrusters is above alt-DAP mode. So that'll be the order of business will be just to go down that priority order for attitude control and maneuvers, and the teams have coordinated those DAP modes, and they'll continue to do that as we go throughout the mission, because there are differences from one activity to the next. The EVAs, for example, I believe on EVA 3, we won't obviously be able to use the momentum manager for part of that EVA, so we'll probably be using one of the other DAP modes again in order of priority.